Hello. Quick video on the Bernoulli Trials and the Bernoulli distribution. A lot of people jump straight past this because they think it's so simple, but it's the absolutely fundamental discrete probability. So what is a Bernoulli trial? Well, this Italian Bernoulli started looking at gambling as ever, and his basic idea was I flip a coin, I either get a head or a tail, and I've got two probabilities. If it's a fair coin, half and half of those outcomes. So I've got a number of successes and failures, and I've got probabilities. Rolling a dice. Well, I could think of it as I get a 6 or I don't get a 6. And I've got, if it's a fair dice, I've got a 1 in 6 there probability, and I've got a 5 and 6 there of not being a 6. What else could I use this for? Well, I test a new part I've just made. It either works or it's got a defect on it. And I could assume that it's got a 99 out of 100 probability of being working and 1 out of 100 of not working. Now, each of those is a Bernoulli trial. It's a one-off event that has an outcome. And this is absolutely central to all of our work on binomials, Poisson, hypergeometrics, all sorts of things, negative binomials. They all fit together through this. So let's be very clear about our terms that we're working in here. So flipping a coin, rolling a dice, that's called a trial. Yeah, that's a Bernoulli trial. And it has an outcome, either success or a failure. So we have to define what success is. But if we have a success, we're going to count those, and X is the number of successes. So if we wanted to get ahead and we got one, then that would be one success. If we got a tail, that would be a failure, so we'd have 0 successes. And the other thing we need is probabilities. So what's the probability of a success is usually called P. And probability of a failure, well, that's going to be complementary probability, which is 1 minus P, which quite often people call Q. So that's our complete setup. And we are counting successes, that's the important thing. So when we look at our probability distribution, the probability of a 1 success, X equals 1, is P. The probability of no successes, X equals 0, is 1 minus P. What are the other things we need to know about this distribution? Well, we want to know the mean number of successes and the variance in number of successes. So let's have a look at the mean, the expected number of x's. Well, we use our standard formula, don't we? Just like we would in a table of values and probabilities, that we take the number of successes and we multiply that by the probability of those successes, and we sum them all up. So in this case, we've only got 2 outcomes. We can have 1 success, which has got a probability of P, or we can have 0 successes, that's got a probability of 1 minus P, which I think you can see means that when we simplify that the mean number of successes we'd expect is P. Okay, next part, variance of the number of successes. Yeah, the variance, sigma squared. Well, what do? The standard formula is we have the distance there, the mean square from the mean. So there's our different distance from the mean, all squared, multiplied by the probability. So if I've got a successful outcome, my X is 1, my mean we found earlier is P, oops, here we go, and we square that and we multiply it by the probability P. If we were unsuccessful, then the number of successes is 0. We take that away from the mean, which is P, we square that and we multiply it by the probability of 1 minus P, and if you rearrange that, collect up, you can see there's some factors here. Therefore the variance of X, variance in the number of successes, is P times 1 minus P. You might also see that written as P times Q. Yeah, that would be the other way of seeing it written. Okay, so here's my summary page. Remember, we're tracking the number of successes in these trials, and we're only doing 1 trial, so it's either 0 or 1, and that's what we're doing. Here's the probability distribution to go with that, which is simple, isn't it? Because we're either having 0 successes or 1 success, and our probabilities of that are either P or 1 minus P. And as a result, we can calculate the mean and variance of this distribution for one single trial, one flip of a coin, one roll of a dice, one test of a part. There you go.